So the daily problem is same tree. And the conceit of this one is we're given two trees and we want to see if they are the same, if they're identical. So they have the same values at the same points. So these would be identical, these wouldn't, even though one of them you could rotate to get the other. This is 1, and then 1 dot left is 2, and this is 1 dot right is 2. And with this problem, we pretty much just traverse through both trees. We have to watch out for a couple of things, namely that we're traversing through both of them in the same way. But other than that, it's there's several ways to do this problem. So I'll start with a recursive one and then do an iterative one. A recursive one, if we start with actually the end, we're going to have something like make sure that the root node we're at is the same, and then make sure that one of the subtrees is the same and the other subtree is the same. So we'll start and say, well, let's outline a base case if both of them are null. So we'll say if P is none and Q is none, return 1, aka return true. And then we'll say if P is none XOR, which means or but not and, so one of them is none. P is none or Q is none, exclusive or, return 0. And then we'll also say if P, and now we're in a situation, we've outlined if both of them are none. We've outlined if one of them are none. So now the only thing that can happen past this point in the code where there hasn't been an early return statement is if neither of them are none. So now we can actually compare the values and say if p.val isn't equal to q.val, return 0. And then we'll say return self.is same tree of p.left and q.left, and self.is same tree of p.right and q.right. Oops. Dumb mistake. Okay. So this is a recursive solution. Works fine. I think it's going to score a little above average on average because it doesn't really have too much fluff to it. An iterative solution, I mean, all you're really doing here is using the call stack as a pretty direct stack, so we could just use a stack. And I'll have like a stack of tuples. So I'll say st equals dq, and then what the syntax is going to look like is we're going to have each element of the stack be a tuple representing two nodes, and we want to compare and see if they're the same. So we'll fill it initially with p comma q. And the reason why we have all these interlaced parentheses, if we just had this is a DQ constructor. So we're saying build a DQ. This is saying this is the type DQ. So we could say type of some existing object equals DQ, and that would return true or false. But if we want to actually build a DQ, we do that. And then we can build it from, we can input a collection to have a DQ that already has elements. So the way that you initialize a DQ to already have some elements is you just initialize it with a list that you build on the spot. And we're going to have a list with one single element that's a tuple with two elements. A little bit confusing, but and now we have this single element in our stack, P and Q. And then we're going to say something like while st, and then at the end we're probably going to have something like return 1, aka return true. If we ever finish the whole stack, that means that we're probably good, because this is a scenario where we're going to find an error along the way, or we won't find an error along the way. So we can kind of already guess that the structure of the code is going to be if something returns 0 or else return 1. That's kind of what we had in our previous example as well, or our previous solution as well. So we'll say while st, and then we'll just reuse these variable names because it's convenient. P comma q is stack.pop, and then we'll say if p is, I mean this part's pretty much the same, and q is none, continue. then we'll say if P is none, XOR Q is none, then return false immediately. Or else stack.pop P.write Q.write, one extra parenthesis because we're popping in a tuple, and then we'll say the same, pushing a tuple, excuse me. I'm speaking all over the place. And then we do the same thing with left. And you could have these in either order, but I'm doing right first because that means that right's put on the stack and then left is put on the stack and then left is taken off the stack. So left is actually done first, which is, I guess, the direction we all read in. So that's the direction that is easier to conceptualize. Oops. And then the last thing we need to do, and actually I wanted to point this out. Earlier I put parentheses around these, and the reason is that the Python compiler is smart enough to understand this. P is none and Q is none. But here, because we're using this XOR, and this, I think it's that this explicitly can only be used on Booleans, whereas the word and is a little different. This XOR means that we need to evaluate these separately, and then this takes precedence. But the other thing I forgot is actually to compare their values here. So we'll also put something like if P dot val is not equal to Q dot val, return 0. Oops, and then this is append. So it's a recursive solution and an iterative solution. I think they're both the same. I don't know why this is showing 50% and the other one was like 80%. Probably use this for the thumbnail.